Welcome to the course on biostatistics and design of experiments. Today we will talk more about t-test. We talked about one sample t-test where you have only one sample and comparing it with the global mean. Okay, then we talked about two sample t-test where we are having two sets of samples and then trying to say whether these samples come from the same population or different population. Like for example, two different drugs you are comparing or two different activities we are comparing or two different instruments we are comparing. Now we will look at paired sample t-test. That means paired sample t-test is nothing but we use the same subject as control as well as the test. For example, I have 6 subjects, okay, because getting healthy volunteers, getting animals could be more difficult. Suppose I want to conduct a drug and a placebo comparison, I may need 6 animals for placebo and 6 animals for drug, or if I want to test it out on human, then I may have to have 6 human volunteers for placebo and 6 for drugs, which is very expensive, time consuming, it requires a lot of resources. So sometimes what we do is we make use of the same subjects, same animals both as the control as well as the test. So in this particular example, I have 6 subjects. I am testing drug, old drug on subject 1 and old drug on subject 2, old drug on subject 3, 4, 5, 6, and I look at the performance. Okay, it could be a glucose blood glucose lowering drug, or it could be a heartbeat lowering drug or cholesterol lowering drug, and then I wait for a few days, so that assuming that the effect of the old drug gets completely washed out, and then I give this new drug on the same 6 volunteers. So the important point is I should give sufficient time so that the effect of the old drug or old treatment or old assay gets completely washed out, and then I am testing the new drug and I am seeing again the effect on the same 6. So if I subtract the effect of the old drug on volunteer 1 with the effect of the new drug on volunteer 1, I get something called the difference here, right. So theoretically, if the old drug and the new drug are the same, the difference should be equal to 0. But if I see a statistically significant difference which is away from 0, then I can say the new drug is different from old drug, okay, or the new treatment is different from the old treatment, and that is what is paired sample t-test. So I take a difference and after that I will perform a one sample t-test with mu is equal to 0. So let us take this example. 75 minus 81 is 6, 159 minus 166 is 7, 115 minus 116 is 1, 191 minus 201 is 10, 123 minus 119, okay. Actually I am doing the other way, actually 81 minus 75 is 6, 166 minus 159 is 7, 116 minus 115 is 1, 201 minus 191 is 10, 119 minus 123 is minus 4, 88 minus 90 is minus 2. Now if I add all these, I will get some x bar, right. I add all these, I will get x bar. I would like to tell whether this x bar is statistically different from the mu of 0. So my h naught will be mu is equal to 0, HA will be mu is not equal to 0 if I want to show that new drug is different from the old drug. I can do a two-tailed test because we are talking about only difference with a degree of freedom of 5, because we are looking at only this data now, 6 data points, we are not looking at the whole lot. It is a two-tailed test, degrees of freedom is 5, p is equal to 0.05, okay. So p is equal to 0.05 for a two-tailed test, degrees of freedom is 5, so my t value is 2.571, two-tailed test, remember that. So 6, 7, 1, 10, minus 4, minus 2, I calculate the x bar and I will try to see whether this x bar is statistically different from mu naught of 0. So 75 minus 8, 6, 7, 1, 10, minus 4, minus 2, the average is 3. So does 3 come from a different population where mu naught is equal to 0. So the standard deviation is 5.51. So, the T I can calculate using this equation. You remember this equation, x bar minus mu naught divided by S divided by square root of n, x bar is 3, mu naught is 0, S is 5.51, square root of 6. So, I get 1.332. Now, T as I told you is 2.571 from the table, assuming 5 degrees of freedom, 2 tail P is equal to 0.5. So, there was no reason for you to reject the null hypothesis, okay, very straightforward. So, this is the T 0.05, okay. So, 5 degrees of freedom we can use, or for a 2 tailed test, the top one is 1 tailed test, bottom one is 2 tailed test. So, for a 5 degrees of freedom 2.571, that is what it is, okay, whereas GraphPad can do 2 sample t test, okay. So, here we do, so array 1 comma array 2 comma I want to see difference, okay. So, it is a 2 tailed test comma, so it is not a oh sorry, it is a pair t test. So, we do a 1 here, okay, pair t test, it is a 1 here. So, we get 0.24. So, here we accept the null hypothesis, okay. Do you understand this? So, we use 1 for pair t test, 2 and 3 for 2 sample t test. We can also do a 2 sample t test. I want you to see what is the result we get, comma, okay, comma, tail is 2, comma, we can say unequal variance 3, okay, p value comes out very large, okay. Even if you take it as a equal variance, p value will come out to be large. So, that way paired t test is much better, okay, as you can see. So, the paired t test is much better than a 2 sample t test. We can do it by the GraphPad software also. So, GraphPad software does a continuous distribution, continue, so we have a pair t test concept here, enter the data here, so we will go to the data set, we will copy one data set at a time, then we will again go to the Excel, we copy another data set, okay, calculate now. It is not statistically significant here, okay, so it is giving 0.91 as the p value, okay, 2 tailed p value equals 0.91, okay, that is here as it is given here, 2 tailed p value. So, here we are doing unpaired t test, whereas if you go and do a pair t test and calculate now, but the difference is not considered. So, it is giving 0.2401. So, same thing here we got, right, okay, we got not significant here, okay, 0.20 and so on. Actually t is 1.3328, okay, 1.332. So, we can do it using the Excel function, okay, which gives you both paired or unpaired 2 sample t test, but remember Excel cannot do a 1 sample t test, okay, whereas a GraphPad can do. And then so 3 different approaches by which we have seen, and we can do this problem that. Now, let us look at another problem with a paired sample. Now, 2 drugs were tested on 8 cats here, okay, drug 1, it is slowing the heart rate. So, the heart rate has slowed on when I give drug A on cat A, I mean cat 1 by -22, that means it has gone down by 22. When I gave drug B, it went down minus 14 and so on actually. Okay. So, the average is minus 17, average for this is minus 6.5. Now, this drug A is more effective than drug B. One way of doing this is we can assume this as a 2 sample t test and do it, or we can also do it by paired. Paired can be done only if you use the same subject for 2 different treatments, in this case drug A and drug B, or placebo and drug, or control and drug. Okay, same subject has to be used. So, I can do minus okay, A minus B is minus 22 minus 14, minus 14 minus 12 and so on. I can add up overall, that comes out to be minus 10.5, that gives you the mean. Now, these are the values. Okay. I can calculate the t. Okay. Here mu naught is equal to 0, so I can say x bar is minus 10.5 divided by 9.8 of and then square root of 8, that will come out to be 3.017. So, I go to the table, H naught is mu is equal to 0, HA is mu is less than 0, T table is 1.895 for 7 degrees of freedom. Let us go to T table. Okay. For the top one corresponds to 1 tail test, bottom one corresponds to 2 tail test. For 7 degrees of freedom 1.895. Please remember, for 95 we are using here 0.05 here, so 1.895. 7 degrees of freedom table gives you for 1 sample t test single tail 1.895, you are calculating it as 3.017. So, what do? Reject null hypothesis, accept alternate, that means drug A lower is more effective than drug B, that means the heart rate is less. Okay. So, you understood. So, here we will also do it by 2 sample t test, we will do that now, but before that I want to show first you subtract A minus B, so it becomes only 1 sample and the mu is equal to 0, that means if there is no difference between the 2 drugs, the mean should come out to be 0. If the mean is different, mean is now x bar of minus 10.5. So, what do? X bar minus mu divided by S divided by square root of n, n is 10, so square root of 10, S is 9.8, x bar is minus 10.5. So, when I calculate I get 3.01, table t is 1.895, 7 degrees of freedom. So, for 1 sample t test single tail 1.895, so you reject the null hypothesis. Okay, let us do the same thing using both Excel and the other software GraphPad. Let us go to Excel. First let me clear the whole thing. Excel cannot do a 1 sample t test, but it can do a paired t test. Okay. So, I take these 2 data, Control C, okay. I am not interested in this. Okay. So, we will do TTST, this data set, comma, this data set, comma, tail is 1, comma, we are talking about pair t test. So, 0.009, okay. 0.009 as you can see here. So, we can say based on the paired sample study we can reject the null hypothesis and accept the alternate hypothesis. That means minus 17 is much less in lowering, that means drug A is much better in lowering the heart rate when compared to drug B. Now, let us do the same problem with 2 sample t test. Okay. So, same command. So, I will do like this, comma, do like this, comma, again it is 1 tail. Now, 2 is equal variance to sample, 3 is unequal variance to sample. So, let me put 3. So, it has come to 0.09. So, this number is much larger than 0.05. That means we cannot reject the null hypothesis, we are in trouble, right. So, when I use a paired sample t test, I am able to see the real differences, I am rejecting the null hypothesis. When I use a 2 sample t test with unequal variance, I am not able to reject the null hypothesis. That means the differences are not being seen in 2 sample t test, and here I am using equal variance. Even here the p value in both these cases, p value is greater than 0.05. So, the null hypothesis cannot be rejected, whereas when I use the paired t test, I am rejecting the null hypothesis. Did you see that? So, the paired t test is more accurate than 2 sample t test, but the point is you need to remember, I need to use the same subjects in both the cases. I am testing drug A and B on the same subject, and then when I take a difference, I expect if there is no difference on the performance of the drug, it should come out to be 0. Okay. So, I will convert these 2 sets of samples into one set of sample by subtracting one from another, and then I will use the equation of x bar minus mu naught here will be 0 because I do not expect to see any difference, divided by s square root of n. Okay. That is what is paired sample t test is. But the important point is, when I treat the subjects with drug A, I give sufficient time and I assume that the effect of drug A is completely washed out, then I give the drug B and then see the effect. So, there should not be any accumulation of the effect of drug A when I give the drug B, then I will not be able to really decipher the 2 effects. Okay. So, here you saw that interestingly, when I do a 2 sample t test, even if you take the average for example, oh sorry, I made a mistake, average, my spelling is bad, A-V-E-R-A-G-E, come on, A-V-E-R-A-G-E. So, this average is minus 17, whereas this average is minus 6.5. It looks very large, but when I use a 2 sample t test, because the variations are so large here, as you can see here the variations are so large that the 2 sample t test gives you a probability of 0.09, which means that there is no statistically significant difference between these 2 data sets, whereas when I perform a paired t test, I am able to say there is a statistically significant difference. Okay. Now, we can use the GraphPad software also. And do the same calculations here. I will take this. Okay, I will take this data, and then I will say paired t test. Okay, calculate now. So, it says by the difference is considered to be statistically significant, the p value comes out to be 0.0195. This is a 2-tailed p value. So, for a 1-tail, because in this problem we want to say drug A is more effective in lowering the heartbeat. So, for a 1-tail 0.0195 divided by 2 is 0.009 and so on actually. So, when I use a paired sample t test, I am able to see the difference. Now, let us look the unpaired t test. Okay, unpaired t test, not statistically significant because my p value comes out to be 0.1859. So, if I divide by 2, because for a 1-tail I have to divide by 2, it will come out to be 0.097, which is much larger than 0.05. So, obviously the p is not significant at 95%. So, there is no reason for you to reject the null hypothesis. So, you noticed this paired sample t test is very powerful because it can see small differences unlike 2 sample t test, whether 2 sample t test equal variance or unequal variance. I showed you if I use Excel or if I use GraphPad, when I run a 2 sample t test, the p value is much higher. So, we will not be able to differentiate between these two drugs. But whereas when we do a paired sample t test where we are subtracting one sample from another sample to get the difference for each one of these cats, and then we get x bar here, our null hypothesis will be mu naught will be equal to 0, but x bar is minus 10.5. we want to know whether it comes from a different population. So obviously x bar minus mu divided by s divided by square root of n is what we try to do, and we find that that t value is much larger, 3.0 when compared to 1.895 for one sample t test single tail 7 degrees of freedom. Okay. So although two sample t test might not be able to give a good p value, when we do a paired sample t test we get a very good p value. Okay. So we reject the null hypothesis. Okay. So we looked at different types of t test. All these t tests are meant for comparing means. Okay. So one sample t test, that means we are comparing the mean of a set of sample with the population mean. Okay. So I take 10 students, I get their IQ and I say the compare it with the IQ of my university. Okay. That is called a one sample t test. In two sample t test we compare two sets of means. So I have performance of one student, I have a performance of another student, then I am comparing these two. I am having a performance of drug A tested on say 10 rats or 10 human volunteers. I am comparing drug B tested on 20 rats or 20 human volunteers. I am trying to see whether they come from the same population or different population. That is called a two sample t test. Then we looked at paired t test where I use the same subjects or same volunteers or same rats as for both control and test, or drug A and drug B. So I subtract the performance because of drug A and because of drug B. If there is no difference between drug A and B, I should get it as 0, right. So then I perform a one sample t test with mu naught as 0. So I use the equation x bar minus mu naught divided by s divided by square root of n. So it becomes a one sample t test. So I take a difference between these because it is paired, and then I perform a one sample t test. So paired t test is quite sensitive, as I showed in one of the problems, whereas a two sample t test is not able to differentiate between say drug A and drug B, whereas when I do a paired t test I am able to see a difference. But one important point you need to keep in mind is when I test this, same subjects with drug A and later with drug B, I have to be sure that the effect of drug A is completely washed and removed, then I test the next drug. Otherwise you will start having combination effect or synergistic effect and so on actually. So you need to keep that point in mind. Okay. But when you are doing clinical trials, you are taking subjects in different parts of continents, different parts of cities, towns, so it is not possible for you to do a paired t test. So you will have different sets of samples. Okay. So you have to do a two sample t test. But one important point we also noticed is paired t test is able to give a very low p value, whereas when we do the same analyze the same data set with two sample t test, the p value increases, then we will not have a chance to reject the null hypothesis. So you should keep that in mind. So all these t tests are meant to compare means. Okay. So one sample t test, to sum it up, x bar minus mu naught divided by s divided by square root of n. So we can use the same equation for paired t test also, because we are converting the two samples into one sample. Then the degrees of freedom is n minus 1. Then we get from the table some t value. Then if the table t value and the t calculated, if the t calculated is less than the table, we accept h naught. If t calculated is greater than the table, we reject h naught. So okay, this is a one tail test because we are talking about mu less than mu naught. If mu is not equal to mu naught, then it becomes a two tail test. Okay, in two sample t test, this is the equation we have. xh bar is the mean of sample 1, xl bar is the mean of sample 2. 2, and then we divide by standard error square root of 1 by nh plus 1 by nl. So, nh is the number of data points for sample 1, nl is the number of data points for sample 2, right, and the degrees of freedom will be nh minus 1 plus nl minus 1, okay, like that. So, this is the equation which we use, okay, for a 2 sample t test. Okay. So, let us in the next class talk about tests that are involved in comparing variances or standard deviation. Thank you very much for your time.